Good evening. I'm Dana Cowley with Contractor Hanford Mission Integration Solutions, and we thank you for joining tonight's virtual public meeting. This meeting is being recorded. Now, tonight's event is to discuss the addition of an acetonitrile distillate loadout facility, tote storage tanks, and extra storage tanks for brine. The new construction will take place at the effluent treatment facility in Hanford's 200 area. These are necessary changes to support the waste management that will result from operations at the waste treatment plant. Tonight's meeting is part of a 60-day public comment period. It began April 6th and it ends June 4th. I'd like to draw your attention to the agenda that's on the screen now. You'll see that tonight's DOE presenters will begin with Richard Valle. We also have support for your questions from DOE's Ricky Bang and Karthik Simarian. And Karthik, I pronounced that correctly, didn't I? Thank you very much. So as we go through, if I mispronounce anyone's names, please correct me. That's not intentional, but I want to make sure everyone is acknowledged. Now, for those of you who are participating using the telephone only, you're on mute. To unmute, please press *6. To return to mute, press *6, and remain on mute during the entire meeting unless you're asking a question. Please do not put the call on hold. If you hang up, there might be background music. Just hang up. Call back in later, and we'll be glad to have you then. You can submit your questions at any time using the chat box, and please just indicate if you'd like us to read your questions out loud or if you'd prefer to do it. If you have multiple questions, please save them until we've gone all around the room and everybody's had an opportunity to ask at least one question. And now that we're through all that, we are ready for Richard Valle to offer the presentation.
Okay, thank you for that. Just wait for the slides to come up. Perfect, thank you. So, as was noted, my name is Richard Valle. I'm a DOE federal employee here with the Office of River Protection, particularly within the Tank Farm Programs Division. And today we're going to be discussing a proposed permit modification in support of one of our facilities here out on site, the 200 area effluent treatment facility. And as was noted, it pertains to the installation of secondary waste storage and loadout capabilities. And we'll provide all the lower level details here in the subsequent slides. But with that intro, if we could please move to the next slide. All right. And for folks that have been joining us in the recent past here, we just always try to take the opportunity to describe one of the main activities ongoing here at the Hanford site. You'll hear that called the Direct Feed Low Activity Waste Configuration, or DF Law. And it's through this DF Law configuration or program that DOE intends to integrate a select individual grouping of projects, facilities, and infrastructure upgrades, all with the intent to retrieve, treat, and immobilize that low activity waste into glass. And if we just take a moment to kind of walk through the graphic here, it's a little bit busy, but we'll start at the top middle with the AP tank farm you see called out to you in gold. That's where the tank waste will be staged for storage prior to pre-treatment. The pre-treatment will occur at the tank site cesium removal. You see the blue call out at the top left, also referred to as TSCR. It's through the tank site cesium removal, or TSCR, that we will remove solids and cesium, pre-treating that tank waste. And then you see a gold flow path leaving the AP tank farm. If your vision's really good, you can see that there's some wording there that says pre-treated law for low activity waste. So that pre-treated waste follows that gold flow path, enters the waste treatment and immobilization plant footprint, and you see that the gold arrow there terminating at the low activity waste facility, or the LAW facility. So that pre-treated waste will then be mixed with glass formers, heat applied, and then the waste will be vitrified into a glass form. And at that point, we'll have glass ready for disposal. So if we follow that glass product, we just recognize that it's then transported to the integrated disposal facility. You see that top left purple call out. That's where that glass waste will be transported for disposal, and that kind of takes us through the storage, treatment, and disposal for that tank waste. But if we just focus our attention back to the low activity waste, or LAW facility, we see we also have a white flow path leaving the facility, and that's a function of the glass making process producing secondary liquid effluent. So again, as part of the glass making process, secondary liquid effluent being generated. That would then follow the white flow path to, you see the first stop there being the effluent management facility with the bright blue call out. That's where we aim to manage the volume of that secondary liquid effluent through evaporation, and any remaining liquid volume would then be sent through the longer white flow path, terminating at the facilities we'll be discussing tonight. You see the more orange call out at the top right, and that's the liquid effluent retention facility, or LERF, and the effluent treatment facility, or ETF. All right, so with that, we'll move to the next slide, please. And this slide kind of just gives you that continuation, probably highlighting some points here worth reiterating in the bullets. Nothing we haven't heard or seen at this point, but just reiterating the first bullet there, again, recognizing that secondary liquid waste will be generated as part of the glass making process. And that glass making process or vitrification will occur at the Waste Treatment and Mobilization Plant, or WTP. That secondary liquid waste that's generated will then be managed through evaporation at the WTP's effluent management facility. And then ultimately, any of the remaining liquid volume there would be sent and transferred to the liquid effluent retention facility, or LERF, and the 200 area effluent treatment facility, or ETF. You'll see them grouped together usually. And they will be used to manage and treat that EMF evaporator condensate. So the graphic on this slide, we just want to focus on the effluent management facility and its evaporating capabilities. So just making sense of this very quickly, we see we have a evaporator feed from the low activity waste facility entering a feed vessel, and then it's then routed to the evaporator, so really the heart and soul there. And we see we have two waste streams exiting the evaporator. The bottom, you see evaporator concentrate being rerouted back to the low activity waste facility, and you'll hear that referred to as evaporator bottoms. And then you see we have a arrow leaving the top of the evaporator in a vapor form. Then you see being condensed back down, mixed with a caustic scrubber effluent stream, and that ultimately ends up at a collection vessel prior to transfer to the liquid effluent retention facility. So the takeaway there being evaporator overheads usually refer to that top vapor phase that gets condensed back down. So with that, that kind of explains the evaporator overheads and the evaporator bottoms. Next slide, please. Okay. Shifting gears now more to the regulatory frameworking that we're operating under. We recognize that at Hanford here, the Resource Conservation and Recovery Act, or RCRA, provides us with a permit that governs dangerous waste treatment, storage, and disposal here at the Hanford site. This RCRA permit is regulated by the Washington State Department of Ecology and issued to us, the permittees, and we are currently operating under Revision 8C of this RCRA permit. As we noted, we, the permittees, are DOE, and in this particular instance, our contractor being Washington River Protection Solutions, are proposing a Class 2 permit modification to this RCRA permit, in particular to the LERF and 200 area ETF permit sections, which you'll see referred to in our permit as Operating Unit Group 3. Next slide, please. Right, the next couple slides kind of get us towards the facility in question for tonight, but you see it here on slide 5. We're starting at a high level. So you see the Hanford site located within the state of Washington. The Hanford site's comprised of a series of areas, and we'll be focusing our attention on the 200 East area. And then for the facility of discussion tonight, you see the general call out there in white for the liquid effluent retention facility, or LERF, and the 200 area effluent treatment facility, or ETF. Next slide, please. Here's one step lower where we have an aerial view of the two facilities. Again, they're usually grouped. So you see the LERF at the top of the photo, currently consisting of 3 operating surface impoundments. We see the black floating cover that sits atop the liquid waste. And then to the side in the dotted box, we see the location for the 4th surface impoundment or basin that's currently being installed. And so we will eventually have 4 operating surface impoundments or basins. But really our main area of discussion tonight is at the bottom of the graphic. So the effluent treatment facility, or ETF, is called out for you there. And we see the different building systems and structures that comprise of the effluent treatment facility. And we'll go one step lower here in a second. Next slide, please. While we have this aerial view up, we did want to note, and you see it called out there in that gold shaded area, that's really where all the proposed modifications that we'll be discussing tonight will be proposed for installation. So again, while we had the graphic up, we wanted to kind of provide a precursor on where we're going to be discussing or focusing our attention for discussion tonight, excuse me. Next slide, please. All right, and at this point, we've now drilled down to just the 200 area effluent treatment facility. Again, this is where the bulk of the discussion will be focused. The function of the 200 area ETF is to treat liquid waste from Hanford site sources. And as we've noted, operations will expand in the very near future to include the management of this WTP DF law effluent. So the photo you see here is of the secondary treatment train. For folks familiar with our permit, the secondary treatment train is where waste within the ETF is concentrated. And again, the focus of tonight's proposed modifications will primarily focus on the secondary treatment train. So we wanted to provide a visual, but because there's concentration occurring here, you can see the shielding that's related to that with these concrete walls. Okay, next slide, please. So in terms of a flow sheet for visual indication, this is a before photo, or I'm sorry, not a before photo, but a before schematic prior to any of the proposed modifications. So this is existing today. We see in gray the various systems that are able to send waste to the effluent treatment facility, and it's first treated in the primary treatment train that's shown to you there in blue. The primary treatment train then has reject streams, and you see that in a green arrow that leaves the primary treatment train and then provides the waste for the secondary treatment train. Again, the focus of our discussion tonight will be on the secondary treatment train, but you see currently existing today, we have secondary waste receiving, we have an evaporation step, a concentrate staging step, and then we have the ability today to either route that concentrated waste to thin film drying or brine loadout. So if we take a mental snapshot and then jump to the next slide, this is really the focus of tonight's discussion with these proposed modifications. So you see we still have the same existing system grayed out here, and we've highlighted the new systems that we're proposing. You see the call out there with the orange box. So these proposed modifications are called out by this permit mod. And if we just start after concentrate staging, we see we now have the ability to still send to brine loadout, but have the ability to also send waste to the brine storage tanks. We'll describe more of these in detail. At the back end of the primary treatment train, we now have, or are proposing, a stream that routes to distillate storage. The distillate storage feeds the distillate loadout system, and then the distillate loadout system has a tote storage capability that's being proposed tonight. So if we jump to the next slide, hopefully these proposed modifications, once incorporated, will then look like what you're seeing here on slide 11, where our secondary treatment train will then be expanded to include these additional capacities and capabilities. Next slide, please. So up until this point, we provided a lot of background to provide some context on the facility and kind of existing systems. We talked a little bit about what's being proposed. These bullets on slide 12 and 13 really summarize the proposed modification. So before getting into the specific bullets, just the precursor text there provides an overview of why these systems are needed. So we did receive a certified waste profile from the waste treatment plant. Waste Treatment and Immobilization Plant, WTP, that described the WTP DFLAW effluent, and that included the volume and composition of that waste stream. It was reviewed by DOE and our contractors at the effluent treatment facility, and it was determined that changes would be needed to adequately address and adequately manage this new WTP DFLAW effluent waste stream. So because of that, we are proposing in these bullets, first one there being the installation of what we're terming brine storage tanks. These, as we previously alluded to, would provide additional storage capacity and operational flexibility to load out that waste stream into totes. Proposing the installation of what we're terming acetonitrile distillate storage tanks, which would provide additional storage capacity after supplemental organic treatment. Moving to the next slide, please. We are then proposing the installation of a new facility, an acetonitrile distillate loadout facility, to provide the capability to transfer waste into totes prior to off-site treatment. And then the last bullet there notes that there would be a tote storage area, again, to provide some storage capacity prior to that off-site treatment. And we'll explain each of these bullets in a little more detail here in the coming slides as well. Next slide, please. All right, so we took the opportunity in slides prior to kind of highlight this general area. And this is, again, to just provide some insight on a lot of where really where all these proposed installations would be placed. So this is a higher level, and we'll drill down one step lower on slide 15, please. And here we see on the left the before photo. So it's just that gold box in the slide prior, now zoomed in. And on the after, you see on the right, we've superimposed the proposed modifications, and again, not necessarily being to scale, but they do provide a general relation on where these would be placed. So starting at the top of the photo and working our way north, as the compass indicates, we see the brine storage tanks provided within that concrete pad, that's the rectangle. And then we see the proposed brine storage tanks that would be installed within their concrete pad. Going further north or down the slide, I know it's a little confusing with that regard, but we then see the acetonitrile distillate storage tanks. Again, the rectangle there being the concrete pad in which these two tanks sit. The distillate storage tanks would then feed that new acetonitrile distillate loadout facility, and then the loadout facility would then have a storage capability in these tote storage areas that you see called out to you as well. Okay, next slide, please. So then this provides the lower level detail for each of those individual scope elements. The intro text there is no different than what we saw before. So again, the installation of what we're proposing here and terming the brine storage tanks would provide storage capacity and operational flexibility to load out that waste into totes. Through this permit modification, we are proposing the installation of 3 stainless steel tanks. They each would have a tank capacity of 25,000 gallons. As we noted prior, they would sit within a concrete pad exterior to the ETF building. And as you probably saw on the slide prior as well, they are sized for future expansion, or that pad is. This system would have all the requisite secondary containment provided by the floor and berm walls, with special protective coating applied, and then that secondary containment would slope to a low point sump equipped with its own leak detection capability. Next slide, please. All right, we've seen this photo before, but we've taken the opportunity to kind of provide a little bit more detail. So we see, again, the rectangle being the concrete pad within which these tanks sit. Within this permit modification, we are proposing the installation of 3 brine storage tanks, but you can see there the room for future expansion. And then in the zoom-in version, we just wanted to provide an example of what one of these tanks would look like for reference as well. And you can see that in the gold call-out. Next slide, please. Okay, now shifting over to the distillate storage tank. So again, proposing the installation of what we're terming acetonitrile distillate storage tanks to provide storage capacity after supplemental organic treatment. Similar to last, you can see these bullets follow a pattern. So we are proposing the installation of 2 stainless steel tanks, again with a capacity of 25,000 gallons. These 2 tanks would sit within their own concrete pad exterior to the ETF building, and then similar to last, they would have the requisite secondary containment provided by the floor and berm walls with secondary protective coating applied. The floors would slope towards a low point sump and would have their own leak detection capability as well. Next slide, please. Here's that same similar layout. So we see for the distillate storage tanks, again, a rectangle represents the concrete pad that these tanks would sit within. You can see the 2 tanks being proposed and how they would sit within this concrete pad. And then we wanted to provide the ability to see what these would look like a little bit more 3-dimensionally, so you can see the call out there in gold with an example of one of these distillate storage tanks would look like. Next slide, please. And now moving to the distillate loadout facility. So proposing the installation of, again, this new facility termed the Acetonitrile Distillate Loadout Facility. This would provide the ability to package acetonitrile distillate waste into totes for off-site treatment. So from the slide prior, or the scope from the slide prior, so from the distillate storage tanks, that waste would then be routed to this new acetonitrile distillate loadout facility. The facility would have 2 fill stations where a forklift would be used to load and unload. Forklift would be used to load and unload 350-gallon stainless steel totes. And then similar to prior, this building would have the requisite secondary containment provided by the floor, and here would be applying the secondary protective coating as well. The flooring would slope to a low point sump and would have its own leak detection capability as well. Next slide, please. So we're following a similar pattern. Here we see at a high level what the facility would look like, and then maybe want to focus more of our attention to the gold call out. So we see a select system shown to you. If we tried to include all of it, it would look very busy, but you can see we've tried to call out some of the systems here that are pertinent for discussion. So at the top of the facility, we see roll-up doors where forklifts would be able to enter the facility. Again, then they would load and unload those 350-gallon stainless steel totes within a tote fill station. Excuse me. And then you see in the example we have here, 2 operators performing some manual manipulation to connect a lance or a filling capability, so that waste is then introduced into those totes, filled, and then forklifts would then back out through the roll-up doors to one of the scope elements we'll be discussing next. But then also worth noting on this, the sump that we described prior, and then this being its own facility, has heating, ventilation, and air conditioning, so climate control, as well as a mechanical and electrical room to provide power to some of these systems, powers and other utilities to some of these systems. Next slide, please. And then the last scope element for discussion is the proposed installation of these acetonitrile distillate storage areas. These would provide additional storage capacity for those totes prior to off-site treatment. And so from the new acetonitrile distillate loadout facility, like we had mentioned, forklifts would then be used to unload these 350-gallon stainless steel totes into these new storage units. The storage units would be placed on a concrete pad, and you can see the naming identifiers called out to you there. On the concrete pad, we would be affixing these prefabricated modular storage units, and they're fully enclosed and capable of storing 24 totes each. These prefabricated modular storage units would be equipped with secondary containment, and in the event of a leak, portable pumping system would be able to be installed for transfer of that waste out of either storage unit. Next slide, please. And trying to give some visual context on here. So we see the zoom out, we have the concrete pad and then the two prefabricated modular storage units. We then try to zoom in into what one of these prefabricated modular storage units would look like. So at the bottom of that shape, we see roll-up doors. So we would be able to roll up those doors and then load the totes within the prefabricated modular storage unit. It does have its own heating, ventilation, and air conditioning, so climate controlled. And then at the top of that shape, you can see a side profile with barely making out what the internal rack assembly could look like. So again, the totes would then be placed on that internal rack of storage assembly. Roll-up doors allowed to be closed until ready for off-site shipment. Next slide, please. All right. So as part of this permit modification, there have been changes to the RCRA permit, in particular for the LERF 200 area ETF permit section. And so the bullets here identify the individual addenda that were modified as part of this proposed permit modification. So those include the bullets that are shown there, but we would encourage the public to refer to the specific Hanford Dangerous Waste Permit Change Notice for a full description of the changes. Next slide, please. And then this is kind of just rounding out in summary. Wanted to again reiterate the public process here. So again, we are proposing a Class 2 permit modification to a particular section of the Hanford RCRA permit, that being for the LERF M200 area ETF. This has its own 60-day public comment period that is currently open and will run through the 4th of June. We do encourage you to submit your comments formally, preferably through the electronic means shown in the hyperlink or the URL down below, but also certainly more than welcome to submit physical mail through the address shown below as well. And I think with that takes us to questions, if there are any.
Thank you, Richard. That was quite a bit of detail, and I think we learned a lot from that presentation. I appreciate all your time and effort there. I am looking at the chat, not seeing anyone there. Amber is monitoring the chat. Any contact that you're seeing?
We might have one hand.
I think that's Liz. She's saying thank you so much. She does have a few questions. Liz, *6 to unmute, or you're welcome to put it in the chat and we'll read it for you.
Laura Feldman has her hand raised.
Oh, thank you. Hi, Liz. I see you. Go right ahead.
Thanks so much, Dana. So I just have a few questions, and maybe it would be helpful. My understanding with acetonitrile is that it was assumed that it would be in the treated waste, that DOE is working with PNNL to see if there might be a solution to minimize the concentrations of acetonitrile in the waste that comes out of the low activity waste facility, that it's created in the process of heating up the tank waste that's been treated at TSCR. I don't totally understand. I don't know if there's someone who can talk about the sugars that are, if sugars are added to the glass melter. I know there's been a lot of talk about the sugars and dealing with the sugars. So if someone could address, kind of frame what the issue is in the creation of the acetonitrile, and then the estimated concentrations in the waste that end up being pulled out of the waste at LERF through the ETF. That would be the first thing, if someone could talk to that. Thanks.
Okay, yeah, I think we can go ahead and try to answer that again. The focus of tonight's discussion being on the modification proposed and presented to you today, but I think that question is relevant. So sugars added at the waste treatment plant, as you noted, to be able to vitrify the waste. We can go into a little bit more detail if needed, but that is correct. Sugar would be added as part of the glass making process. Then during the process of generating that glass, the acetonitrile would be formed as a product of incomplete combustion. That would then be, as we noted in the maybe summary slide, work its way through the effluent management facility and ultimately over to LERF ETF for treatment. So all that to say is that we did receive, again, that certified waste profile from the waste treatment plant. They notified us of their chemical composition, and then we used that to design the systems and components that we discussed tonight. So I'll maybe pause there and see if that answered or if there's further detail that may be needed.
Thanks. Well, just one. So I'm curious about, and I think this kind of goes to the mass balance question of tracking kind of start to finish, where all the waste you have to treat and where all the different components go through the treatment process. My assumption would be that when you're looking at your feed tank to TSCR, you're looking at the amount of cyanide in the waste. And then since we haven't sent any waste through the low activity waste melter yet, it's a guess at how much acetonitrile is formed when the cyanide and the sugars mix and then it goes into the off-gas system. Can you talk about the concentrations, how you're estimating the concentrations that kind of go through the system and end up at ETF?
Yep, so there would be no acetonitrile generally in the tank stage for feed through the WTP. The acetonitrile being generated as a product of incomplete combustion with the sugar addition with the tank feed and the glass forming that occurs there. But in terms of concentration, it's again the waste generator, in this case the waste treatment plant, to certify on their waste profile the concentrations of these chemical constituents. And they did that, and they notified us of a concentration for acetonitrile. Our system in particular is designed to be able to adequately treat that concentration, and it's 60 parts per million is what our influent concentration of acetonitrile is designed for. And then again, that is not necessarily the nominal, but the high end, the conservative bounding value that we expect to receive into the LERF 200 area ETF.
And just to clarify, is that then, so the 60 parts per million, is that before it goes through ETF, or is that, I'm a little confused about what's in the brine storage and what's in the acetonitrile distillate totes, and if it's the same waste or kind of how the concentration works. So is that 60 parts per million before it's treated, or is that what would get sent after treatment?
So the 60 parts per million is what would be in the front door of ETF, and then as our current permit outlines, and then the proposed modification tonight kind of further expounds on, that the waste is treated through a series of unit operations that will concentrate that waste. In this particular instance, we're talking the acetonitrile waste stream. So we have incorporated the addition of a steam stripper or steam stripping, also referred to as supplemental organic treatment, that will concentrate the acetonitrile to form a distillate. And then that distillate would then, like we proposed tonight, be routed to a distillate storage tank, a distillate loadout facility, all prior to offsite treatment.
And do you know what the concentration is when it's in, what's the concentration expected when it's through when it goes to the distillate storage tanks?
Yep, and so the acetonitrile would be in that liquid form, and it would be, I know we're changing units on you, but it would be at 2.3 weight percent in those totes prior to offsite treatment, transport.
I have more questions, but I'll wait for others and I'll circle back. Thanks.
Thank you, Liz. Thank you, Richard. I see Laura Feldman with her hand up. Go ahead, Laura.
Hi. I am wondering about the acetonitrile fumes, and maybe you've already addressed this and I just didn't understand the language, but does this proposed modification mitigate those fumes, which I guess are a problem?
Yeah, you hit the nail on the head. So again, we expect the bulk, the vast majority of the acetonitrile, that chemical constituent, to remain in its liquid form. Throughout the process, there's little potential for that to enter a vapor phase to be harmful to the workers or the environment. But we have designed our system to be conservative enough. We've applied a nuclear grade design process to an industrial hazard. The hazard here being the one presented by the acetonitrile chemical. So we have taken that into account through the use of safety factors and margin, and designed a system that is designed for zero release exposure from a vapor of acetonitrile.
Okay, thank you very much.
Turn to the phones now and see if there's anyone joining us by phone who'd like to ask a question. *6 to unmute.
May I join you?
I
May
can
I
hear
ask a
you.
question? Oh, good. I'm Anita in Vancouver, and I was just wondering if there were a power failure in dealing with this waste. Are there backup systems to keep this from becoming a critical mass or otherwise becoming a serious hazard?
So in the case of a power failure for that particular event that you noted, the system does have and was designed for a series of interlocks. And so what those are is the facility operates largely via control room, the control room having computer capabilities to be able to manipulate the specific unit operation. So these interlocks, upon a power loss, would just shut the process down, essentially.
And no problems with this material interacting with itself and becoming a problem?
No, and there would not be. And then it's important to reiterate that in that case, even that case, that there would be no release. Again, we would expect at these pressure temperatures that the waste is operating under, in this case, even shut down, that it would remain in the liquid phase. The acetonitrile chemical would remain in the liquid phase, and there would be no release of acetonitrile vapors that could potentially harm workers or the environment.
Thank you.
Not seeing any more questions in the chat, let's stick with the phone lines. If anyone is on the phone and who would like to ask another question, please hit *6 to unmute. I'm also monitoring the folks who have signed in. I don't see any hand raised. All right, let's see. Oh, Liz, I don't see anyone else wanting to ask a question. You had a few more, so please proceed. We're on schedule to be here until 6:30, so we want to answer all the questions we possibly can.
Excellent. So I just did a conversion for the weight percent to parts per million online. I just want to make sure I did it correctly. So it looks like 2.3 weight percent is equivalent to 23,000 parts per million. Is that right? Did I do that conversion correctly?
That sounds accurate. But
Okay.
Again, just sorry to don't mean to cut you off, Liz, but again, that is in the liquid phase, the concentration within the liquid phase.
Okay. I just want to make sure, since that I don't know that I'm the only one who does not know the conversion between the two. So let me see. So I wanted to clarify that. And then the next question is, so how are you? So we have this concentrated acetonitrile going to Permafix Northwest for treatment. It seemed like Permafix was unaware of the acetonitrile coming, or that component in the waste stream that would be handled. So I guess I'm curious, how is the waste characterization data sent to Permafix Northwest? And then what happens if the acetonitrile levels are still too high for land disposal restrictions? And then where would it go if that's the case?
Yep, so I probably just want a point of clarification there. DOE has not determined yet who that offsite treatment vendor is. So on your particular question there, you noted Permafix Northwest, but we have not made a determination on who that offsite treatment vendor is. What we have done is design the system to be able to package this waste for offsite treatment at multiple potential offsite treatment vendors. So your question on the treatability, so to speak, of the acetonitrile solution, we have performed surrogate testing, and we will continue to perform surrogate testing at the 2.3 weight percent. But our laboratory analysis with that surrogate testing shows that we were able to adequately treat this acetonitrile solution, stabilize it for land disposal. So there's high confidence that that will not be the case, what you said there, with no ability to land dispose.
So just so I know it's a little confusing so you're taking something that's not concentrating it, and then right. Is the idea that does it stay at that concentration when it's put in the waste form that would go into ERDF, or what's the next phase from ETF? Like once it leaves, or once it goes, I mean, I know you don't have the treatment site identified yet, but from the acetonitrile distillate storage totes, kind of right. Like how long, what happens from there?
Sorry. So we have at the back end, those stainless steel totes containing 2.3 weight percent of acetonitrile solution. Those have then been, like we had mentioned, surrogate testing to show that a stabilized waste form exists to be able to land dispose of that material or that waste. So again, 2.3 weight percent in those stainless steel totes. DOE at that point will have selected an offsite treatment vendor. It would be loaded onto trucks for transport for that offsite treatment vendor. And then our work to date has shown that a grout waste form, a cementitious waste form exists to be able to adequately stabilize this waste for land disposal back on site at the integrated disposal facility.
So it would go to IDF then.
That's
and
correct.
Okay, and once it's mixed with grout, how does the concentration change?
So at that point, what I want to say. So the treatment vendor, the offsite treatment vendor, has to certify back to us that the waste form meets land disposal. So we will have, so we don't necessarily, and a lot of it may be proprietary on that cementitious waste form. What we do, and through the surrogate testing, was give them the chemical composition that we intend to send off site. Surrogate testing was performed through the use of potentially a proprietary cementitious or grout-like recipe, and then it was shown that that proprietary cementitious grout recipe was able to meet the land disposal requirements. restriction requirements.
Do you know what the weight percent or parts per million is for IDF disposal?
No, I'm not sure. If you'd like to submit that via formal comment, we can certainly look at it.
Okay. Or is
But
that in the permit somewhere? Right, it might be in the, would it be in the IDF permit?
So
Or in the
maybe,
IDF here?
maybe it's worth going to another level of detail. So the IDF requirement for land disposal of this particular waste stream is stabilization. So we can't send a liquid waste form to IDF. It has to be stabilized because there's a compressive strength requirement of the waste at IDF. So we would be solidifying it to meet that compressive strength requirement for integrated disposal facility. Disposal.
Okay. Is there a concentration limit for land disposal restriction? Is that one of the restrictions?
Not that I'm aware, but again, if you'd like to make that a formal
Okay.
comment, we can respond to you formally.
Okay. And it looks like Mia has a question. I'll let her jump in. Thanks.
Would you like to ask your question, or would you like me to read it?
I can ask it. I'm just wondering, after you take the acetonitrile and it's grouted at the offsite facility, how much the grout increases the volume of the waste that is then disposed at IDF? So by what magnitude, like 2 times the volume, 3 times the volume, just like a rough idea? Thank you.
No problem. That's a good question. And I'd probably refer back to that this offsite treatment vendor, they typically have a proprietary grout recipe or cementitious waste form recipe. So that will dictate the any volume increase as it goes from a liquid to a solid. But I don't think you may be on track with some of the numbers you listed there. We just don't have that information to be able to relay. Ultimately depend on that selected offsite treatment vendor and their ability to how they choose to solidify that waste.
Okay, can I ask a follow-up? You've talked about surrogate testing, which I really do not understand, but with that, were you testing grout on this waste form? Is that what the surrogate testing was doing?
Yeah, that's correct. So instead of sending the actual waste, because we have not generated that waste yet, we were able to develop a chemical analog, a liquid analog, in this case really with the concentration of acetonitrile expected in that liquid form, provided that to a offsite treatment vendor, and then they performed physical testing to be able to certify that they could meet the disposal requirements to solidify that analog.
So for that testing, by how much did the waste volume increase? Do you have any idea, just from that, like the surrogate testing you've done?
I do not. For that, we were mainly interested in whether their proprietary recipe could meet the disposal requirements. Not sure we asked necessarily the full output of what it would look like in terms of that volume you're asking. But if again you want to put that in a formal comment, we can see with our experts on if we have a more sufficient answer there.
Okay, thank you so much.
Sure.
Perhaps we could once again show the email address where people will submit their comments. And I see we have a new question here. We have Dan Solitz joining us. Dan, please go ahead and ask your question.
Thank you. I'm kind of curious, is this and the other solid secondary waste that go into the IDF, will they be commingled with the glass, or will they be kept separate?
So that might be more of a specific question towards the IDF operations. I'll look to see if maybe we have anybody here that may be able to answer that. Can you ask that question one more time?
Okay, thank you. Yes, for the solid secondary waste, this stuff and other solid secondary waste from the treatment of the off gas, will that be kept separate from the glass? A little leery of mixing glass with lime lye, which is what your solid secondary waste is made out of.
So I mean, to try to give you an answer here, I think you're correct that the IDF will receive the glass waste form, and then in this instance, the stabilized acetonitrile waste form. But might depend on your meaning of the word commingling there.
Those are going to be in the same stack? Is going to be anywhere near the same stacks as the glass?
Yeah, I'm not sure we have an exact answer to that. I'd probably ask if you could please submit that formally. It will be within the IDF is probably the answer we can provide here today.
That address is on the screen now.
Yes, we've got the address up there. You can send a written comment to Dana McFadden, Washington State Department of Ecology, 3100 Port of Benton Boulevard. That's in Richland, Washington, 99354. Or our preferred method is electronic, and you can see the link there. It's also in the Hanford.gov events calendar. So, Gandower, did we answer your questions, or did you have anything else you'd like to ask?
Not at this point.
Oh, we have one more response. I apologize. Please go ahead.
So this is Karthik from WRPS. The cementitious waste form and the glass waste form will be adjacent to each other in IDF as it's in the performance assessment, but bottled as a whole.
Thank you. And Ricky, did you have anything further you wanted to add?
And just to clarify, between the grout and the glass, they're in their own separate containers within the IDF.
Thank you both.
Yes, thank you. I am not seeing any hands raised. Amber, do you see anyone in the chat? Liz has some more follow-on questions. Thank you, Liz. I don't see anyone else looking to answer a first question, so please go ahead.
Thank you. Can you explain how the concentrations differ between acetonitrile in the liquid form versus the vapor form, and if you know how that's calculated?
Yeah, I may have to turn over to Karthik here, WRPS Engineering, but maybe to start out, I will say that that is dependent on the chemistry and physical characteristics of the waste, so temperature dependent. And then there are coefficients and different waste characteristics that govern the driving of that chemical constituent from liquid to the gas. And so with that, I may see if Karthik wants to step in.
Yeah, Liz, is Karthik. So it's calculated, we calculated a Henry's law constant from a test, and then utilize that as a function of temperature and calculate what will be the vapor phase concentration above a solution. It's kind of straight chemistry.
Do you know what, it seems like in terms of the worker hazard, it starts at the law facility, and if there's a chance that any of the vapors escape the off-gas system as it's going through after the law melter, and then on its way to the LERF basin. I imagine, like, I don't know how much of a hazard it is for just evaporation. I know the LERF basins are covered. And then it sounds like it's mostly, and I don't know if this is the right terminology, just engineered controls to keep the vapor hazard away from workers. So I'm curious if you know, like, how how the worker hazard, like how are worker breathing zones going to be monitored in case there's a failure of any of those systems, and kind of how you're predicting what the concentration might be in the vapor form.
Yes, Liz, Ricky Bang here. I think I'll start off by starting with the WTP Law facility that their off-gas system is fully enclosed, and they have a very robust and rigorous design in their off-gas system to keep the off-gas contained. Now, once the acetonitrile is condensed into a liquid and then transported to the LERF, we don't anticipate a hazard with acetonitrile at LERF. The temperatures and pressure at LERF don't pose a acetonitrile hazard. It's maintained in the liquid form. As it gets fed into the ETF, again, the operating parameters through the primary treatment train don't pose the hazard, and acetonitrile is then concentrated in the steam stripper and condensed back into the liquid phase following the steam stripper treatment. Again, that is a fully enclosed system, and based on the operating temperatures and parameters, the hazard is controlled by the design that is in place at the ETF. There are multiple levels of controls, including the monitoring and control of the flow rates, the temperatures, and the pressures of the operating units. And there are several levels of design margin, safety margin, and operating margin to ensure that the system operates within our operating limits. And of course, we will have monitoring in the future once ETF is operating under this DF-law configuration to maintain safe conditions within the ETF. I'll start with that and ask if there's any follow-up or additions on our side as well.
Yeah, this Karthik, I think you heard Liz, that the LERF concentration is at 30 parts per million conservatively, so which is well below the concentrations that's coming from WTP. It's already a very, very dilute concentration and won't challenge any of the limits given in the liquid phase.
I guess a follow-up is, how is it more of a hazard for the treatment once the acetonitrile distillate totes go to whatever offsite vendor is going to mix this with grout? It seems like that would be the riskiest part potentially in terms of vapor hazard.
Liz, because the acetonitrile is captured in that liquid phase and then it's stored inside the stainless steel containers and totes, it won't be, and under transport with the weather conditions that we have in the Tri-Cities, it won't pose a hazard during the transport at the Hanford site.
Sorry, I didn't mean the transport. I meant in mixing it with grout, like the actual treatment of the waste.
At this time, we haven't selected a vendor for the solidification process.
Okay, I understand that. I just mean whoever's doing it, it would have to be a pretty carefully handled process.
It would still be, the acetonitrile would still be in the liquid, and then in the future in the solidified state, and not in a vapor phase.
Okay. Is that because the grout isn't heated up? Heat seems to be the enemy here to get to a vapor phase, or does it have any off, like does the liquid not off gas at all? Or I don't really know how it works.
I guess I'll take that. Yes, it does off gas, and it's a function of temperature. And so you will get, since grouting is a low temperature waste form, it holds much of that at very low off gas, dependent on the partial pressures above the liquid. Again, all calculatable.
Thanks, that's helpful. And thanks for answering all of my questions.
Yes, we have come up on the 6:30 mark, and so wanting to be grateful for our participants and respectful for our presenters, let me do one last round of calls for questions before we conclude. Is there anyone in the chat who would like to ask one final question? And anyone on the phone? Press *6 to unmute, and we'd love to answer your final question. Well, in conclusion then, not hearing any more questions, a special thanks to our presenters. I can tell the hard work and effort put in. A thank you to everyone who came. Your comments are always appreciated. A thank you for the support team who's been here conducting this meeting, and a special thank you to our regulators working with us on this RECPA permit. So on behalf of DOE, we want to thank everyone for participating tonight. Please submit your comments to the address on the screen. We prefer electronic, but will of course always accept mailed comments, and we thank you for your input. We appreciate your feedback too. There's a link to an evaluation form in the chat box. If you can fill that out, tell us how we did tonight. Hopefully we can do better in the future. We appreciate your comments and your time. We hope you have a wonderful evening.